It's the biggest question. Maybe it's the only real question. Why is there all this stuff? Why is there a world, a sun, stars, galaxies? Why is there anything at all? Why isn't there just nothing? And from that, the next question just tumbles out. Could all this, everything we see and are, have come from absolutely nothing? Not a dark, empty space, not a void waiting for a spark, but pure, total, absolute nothing. No space, no time, no rules, no potential, nothing. Our first instinct, our gut feeling says no. Of course not. It's a silly idea. Look around, everything comes from something. A tree comes from a seed. The seed came from another tree. You came from your parents. The chair you're sitting on was made from wood and metal by people in a factory. The wood came from a tree. The metal was mined from the ground. You can keep tracing it back, and you always find a prior cause. Something that came before. This idea is baked into our brains. It's how we survive. If you see a ripple in the water, you look for the stone that was thrown. If you hear a noise in the dark, you assume something made it. You don't assume the noise just appeared out of thin air, from total nothingness. That would be crazy. Our entire experience of reality is based on cause and effect. A causes B. B causes C. It's an unbroken chain. The ancient Romans had a phrase for it. And ex nihilo nihil fit. Out of nothing, nothing comes. For thousands of years, this was just common sense. It wasn't really debated. It was an obvious truth about the world, as certain as the sun rising in the east. If you have a box with nothing in it, and you leave it alone, it will always have nothing in it. You don't come back a week later to find a rabbit and a top hat inside. The rule is simple: you can't get something from nothing. This very simple, very powerful idea is the starting point for a lot of deep thinking. Philosophers took this common sense notion and turned it into a formal principle. A man named Gottfried Leibniz called it the principle of sufficient reason. It sounds fancy, but it's basically the same idea we all have. For anything that exists, there must be a reason or a cause for its existence. Things don't just happen for no reason at all. There has to be an explanation, even if we don't know what it is. So if the universe exists, it must have a reason. It must have a cause. You can't just say, well, it's just here. That's not a good enough explanation for a philosopher like Leibniz. It's an intellectual dead end. This line of thinking forces you to keep asking why backwards in time. Okay, the Earth came from a cloud of dust and gas. Where did that cloud come from? From an earlier star that exploded. Where did that star come from? From an even earlier cloud of gas. And you go back and back and back. You trace the chain of cause and effect. Eventually you get to the Big Bang. A point, about 13.8 billion years ago, where everything in the known universe was compressed into an incredibly hot, dense state. And then it expanded. That expansion is the universe we see today. But the question doesn't stop. It just changes. What caused the Big Bang? What was there before it? This is where the chain seems to break. And this is where the old philosophical arguments really dig in. If everything needs a cause, then the Big Bang needed a cause. And the cause of the Big Bang needed a cause. You can see the problem. You get stuck in an infinite loop, a never-ending chain of causes going back forever. This is called an infinite regress. Some thinkers were fine with that. Maybe the chain just goes on forever. Maybe there was always something. But for many, that felt unsatisfying. It felt like a dodge. It doesn't actually explain anything. It just pushes the problem back an infinite number of steps. So, they proposed a different solution. The chain of causes can't go on forever. It must, at some point, stop. There must be a first cause. Something that started the whole chain reaction but was not itself caused by anything else. An uncaused cause. This thing would have to be different from everything else in the universe. Everything we know is contingent. That means it depends on something else for its existence. You're contingent on your parents. The Earth is contingent on the sun. But this first cause would have to be necessary. It would exist by its own nature. It wouldn't need a cause. It would just be. This is an incredibly powerful idea. It solves the problem of the infinite loop. The buck stops here. You have a final answer to the question of where did it all come from? It came from this first uncaused thing. Of course, when you start talking about an eternal, uncaused, necessary being that created everything, it sounds a lot like God. And for centuries, this was the primary philosophical argument for the existence of God. Thomas Aquinas, a medieval monk and philosopher, laid it out in his famous 5 ways. The first way is the argument from motion. Things are in motion. Anything in motion must have been put in motion by something else. This chain can't go on forever. Therefore, there must be a first mover and unmoved mover. And this, he said, everyone understands to be God. This provides a neat and tidy answer to our question. Can something come from nothing? No. Ex nihilo nihil fit. Everything, including the universe, must have a cause. That cause is a necessary being, God, who exists outside of time and space and is not caused by anything. So, the universe didn't come from nothing, it came from God. This answer has satisfied billions of people for thousands of years. It feels right. It aligns with our intuition that things need a creator. A painting has a painter. A symphony has a composer. A universe has a universe maker. It's clean, but it doesn't close the book. Because an inquisitive mind, especially a skeptical one, will immediately ask the next logical question. Okay, so where did God come from? The answer from theology is simple. God didn't come from anywhere. And God is the uncaused cause. The question itself is flawed because it tries to apply the rules of our universe, cause and effect, to something that exists outside of it. God is eternal. God just is. Asking what caused God is like asking what's north of the North Pole. The question doesn't make sense in that context. For believers, this is a sufficient answer. The ultimate reality is a conscious, eternal mind. But for a non-believer, this can feel like a cop-out. It feels like you just replaced one mystery, where did the universe come from, with an even bigger mystery, where did this all-powerful, eternal being come from? You haven't solved the problem of an ultimate origin, you've just given it a name. You've declared one thing to be exempt from the very rule you used to get there. You said everything needs a cause, and then you said, except for this one thing. It can feel like special pleading. So the philosophical and theological paths give us a fork in the road. One path says the universe came from a pre-existing, necessary being, and this solves the problem. The other path says that's an unsupported claim that just pushes the mystery back one step. And so the question remains open. Can something come from absolutely nothing? Philosophy and religion give us a framework, but not a definitive, universally accepted answer. This is where science steps in, and this is where things get really, really weird. Science doesn't deal in philosophical proofs or divine beings. Science deals in observation, evidence, and mathematical models. For a long time, science didn't even touch the question of ultimate origins. It was considered a question for philosophy or religion. Science was busy figuring out how the universe works, not where it came from. The Big Bang Theory changed that. It gave us a scientific starting point. We could rewind the cosmic clock and see the universe emerging from this hot, dense state. But the theory itself has a limit. As you get closer and closer to that initial moment, the laws of physics as we know them, particularly Einstein's theory of general relativity, break down. The math gives you nonsense answers. That initial moment is called a singularity. It's a point beyond which our current science cannot see. So when someone asks a cosmologist what happened before the Big Bang, the most honest answer is, we don't know. Not only do we not know, but the question itself might be meaningless. Since space and time as we understand them began with the Big Bang, asking what happened before could be like asking what's north of the North Pole. Time itself may not have existed. For a while, this was the scientific boundary. The origin of the universe was a mystery locked behind the door of the singularity. But in the last few decades, some physicists have tried to peek behind that door. They've done this using our other great theory of the universe, quantum mechanics. Well, quantum mechanics is the science of the very, very small. It governs the world of atoms and subatomic particles. And its rules are bizarre. They are totally alien to our everyday experience. In the quantum world, particles can be in multiple places at once. They can pop in and out of existence. Certainty is replaced by probability. It's a world of fuzziness, randomness, and potential. And this is where the definition of nothing starts to get slippery. When a philosopher talks about nothing, they mean the absolute absence of everything. No matter, no energy, no space, no time, no physical laws, no potential. A true void. Let's call this philosophical nothing. But when a physicist talks about nothing, they usually mean something different. Then they might mean empty space, a vacuum. But a quantum vacuum is not philosophical nothing. It's not empty. Not at all. One of the cornerstone ideas of quantum mechanics is the uncertainty principle. It says you can never know certain pairs of properties of a particle with perfect accuracy. For instance, you can't know both the exact position and the exact momentum of an electron at the same time. There's a similar uncertainty relationship between energy and time. Because of this, the energy in any given patch of empty space is never perfectly zero. It fluctuates, it bubbles and froths with energy. And because of Einstein's famous equation, EMXE2, energy and mass are two sides of the same coin. This means that these energy fluctuations can, for very brief moments, create pairs of virtual particles. A particle and its antiparticle can spontaneously pop into existence from the empty vacuum, exist for a fraction of a second, and then annihilate each other, disappearing back into the vacuum. This isn't just some wild theory, we have evidence for it. The Casimir effect is a perfect example. If you take two metal plates and place them very, very close together in a vacuum, they'll be pushed toward each other. Why? Because the space between the plates restricts the kinds of virtual particles that can pop into existence there, while the full range of particles can still pop into existence on the outside of the plate. This creates a tiny pressure difference, pushing the plates together. This effect has been measured. It's real. So the quantum vacuum, the physicist version of nothing, is actually a boiling, bubbling sea of temporary particles. It is a thing. It has properties. It has structure. It is governed by the laws of quantum mechanics. It is most definitely not philosophical nothing. This brings us to a mind-bending proposal, most famously put forward by physicist Lawrence Krauss. His idea, and others like it, is that the entire universe could have arisen from this kind of nothing through a quantum fluctuation. The logic goes something like this. One of the strange properties of our universe is that its total energy appears to be very close to zero. How can that be? The universe is full of matter and energy, but there's also gravity. Gravity is a form of negative energy. When you add up all the positive energy of matter and radiation, and you add up all the negative energy of gravity, holding it all together, the two numbers might cancel each other out perfectly. The universe could be the ultimate free lunch. If the total energy of the universe is zero, then you don't need to violate the law of conservation of energy to create it. You can, in principle, create a zero-energy universe from a state that also has zero energy. And what state has zero energy? The quantum vacuum. Nothing. So the model is this. You start with a quantum vacuum. No space, no time, no matter. Just the potential for existence governed by the laws of quantum mechanics. Then a random quantum fluctuation occurs, like the ones that create virtual particles all the time. But this is a big one. This fluctuation creates a tiny bubble of space-time with zero total energy. This bubble then undergoes a period of rapid expansion, what we call inflation, which smooths it out and blows it up to enormous size. That's our Big Bang. That's our universe. In this scenario, the universe came from nothing. Something from nothing. But here is the crucial point, and it's the source of a huge debate between scientists and philosophers. The nothing that Krauss and other physicists talk about is the quantum vacuum. And as we've seen, the quantum vacuum is not philosophical nothing. It is a something. It is a physical entity with a complex structure governed by a pre-existing set of sophisticated mathematical laws, the laws of quantum mechanics. So, the scientific model doesn't show how you get something from absolute philosophical nothing. It shows how you can get a universe from a very specific and potent kind of something, the laws of physics in a quantum vacuum. The critics of this idea, mostly philosophers but also some scientists, are quick to point this out. They argue that the physicists have hijacked the word nothing and redefined it to mean something else. They say that answering where did the universe come from with it came from a quantum vacuum just pushes the question back again. Okay, but where did the quantum vacuum and the laws of quantum mechanics come from? And to that question, science has no answer. The laws of physics just seem to be. We don't know why they are what they are. We don't know why the charge of an electron is what it is, or why the speed of light has its specific value. We don't know why the laws of quantum mechanics exist at all. They are the bedrock of our scientific understanding of reality. We can use them to describe the universe, but we can't explain their own origin from within science. This leaves us in a very strange place. We have two very different kinds of nothing. Can something come from scientific nothing, a quantum vacuum? The model seems to suggest yes. It's a plausible, though not yet proven, scientific hypothesis that a quantum fluctuation in a pre-existing vacuum, governed by pre-existing laws, could have created our universe. But can something come from philosophical nothing, the absolute absence of anything, including physical laws? This is a much harder question. Science, by its very nature, may be unable to answer it. Science is the study of things that exist. It requires a subject to study. It needs some kind of reality, some set of rules to operate. How can you scientifically study a state of absolute non-being? What experiment could you possibly run? What could you measure? The concept of absolute nothing might lie permanently outside the realm of scientific inquiry. So we circle back to the original dilemma. We are faced with a few possibilities, none of which are entirely satisfying. Maybe the universe came from a creator, a god, an uncaused cause. This gives a direct answer but requires a leap of faith. It accepts a being that is exempt from the rules of causality. Maybe the universe came from a pre-existing set of physical laws and a quantum state. This is a scientific possibility, but it leaves us with the brute fact of the laws themselves. Why those laws? Where did they come from? We've replaced the mystery of the universe's origin with the mystery of the origin of its operating system. Maybe the universe has always existed in some form. Perhaps our Big Bang was just one event in an eternal cycle of bangs and crunches. Or maybe our universe is just one bubble in a vast eternal multiverse of other universes all popping into existence. These ideas are popular in some areas of theoretical physics, but they are incredibly difficult, maybe impossible to test. And they still don't solve the ultimate problem, they just push it up a level. Okay, where did the multiverse come from? Or maybe, just maybe, something really can come from absolute philosophical nothing. Maybe our deepest intuition, the one that has guided us for millennia, is just wrong. Maybe ex nihilo nihil fit is a rule that applies inside our universe, but not to the origin of the universe itself. What would that even mean? It would mean that at some point, there was no thing, no space, no time, no laws. And then, for no reason at all, there was something, not caused, just happened. This idea is deeply unsettling to the human mind. It violates our core need for reason and explanation. It feels like a logical absurdity. And yet, some philosophers and physicists have contemplated it. They suggest that perhaps the existence of nothing is fundamentally unstable. That a state of pure non-being is, in some strange way, less natural than the existence of something. But this is deep speculation bordering on poetry. So where does that leave us? It leaves us with a profound sense of humility. The question, can something come from absolutely nothing, pushes up against the absolute limits of human knowledge. We have tried to answer it with logic, with faith, and with science. Each approach gives us a piece of the puzzle, but none gives us the whole picture. Logic and philosophy give us the stark choice between an infinite regress, an uncaused first cause, or the brute fact of a universe that just is. Religion gives us an answer in the form of a creator, an answer that provides meaning and purpose for many, but remains an article of faith for others. Science gives us a tantalizing model of a universe born from a quantum vacuum, a nothing that is really a something. It is a powerful idea that replaces a supernatural origin with a naturalistic one, but it leaves the origin of the laws of nature themselves a complete mystery. Perhaps the problem is in the way we ask the question. Our minds and our language are built to function within this universe, within the framework of time and causality. We are like fish trying to comprehend the concept of dry. We might be fundamentally unequipped to grasp a reality or a non-reality that existed before time and outside of space. The truth is, we don't know, and maybe we never will. It's possible that this is one of those questions that humans will ask forever, with each generation finding new ways to think about it but never reaching a final, conclusive answer. But the search itself is what matters. It's in wrestling with this ultimate question that we have developed philosophy, theology, and science. It's the engine of our curiosity. The desire to know why there is something rather than nothing is what drives us to look up at the stars and to peer into the heart of the atom. We are born into a universe that already exists. We find ourselves here, on a small planet looking out at an incomprehensibly vast cosmos. We didn't ask to be here, we just are, and our existence is the most powerful piece of evidence we have. There is undeniably something, and for now the story of how this something came to be, whether from a different something or from an absolute nothing, remains the greatest mystery we have ever faced.